Hi, I'm working within software development, and this channel is my initiative to share knowledge and help others to understand a language, library, tool, idea, something what I am using. There is a chance that I understood or remember something wrong, or I could say it in a wrong way, so please take this information with, let's say, pinch of salt or and critical thinking. Thanks. This video will cover build process related to the C++ compiler linking part. How can we use make within this process and how can we use CMake? We will not use CMake or make too much. This video will not cover too much CMake or make commands, but it will show overall process of the building the code into an executable file. The example will be written on the C or C++ code. We'll use C or C++ functions depending on the context of a task. Since it is just the start of the course, let's say, about CMake, make, and C++, some of the functionality will be described a little bit later. So, if we're talking about CMake, make, let's take a look firstly about the theory or background. Let's start with stage 0, theory, or let's say background. CMake is a cross-platform family of tools designed to build, test, and package software. Mostly it is working together with C or C++ language. But what it does on the practice. I'm planning to use an evolutional approach and start with the C++ compiler first, then with source files and compilation process. We will start with really simple task. First of all, we want to print a message on the screen. Yes, it is quite old-fashioned task, but let's do it first. So we want to print a message on a console. We want to use C or C++ code, and tools are used. Windows Subsystem Linux, it is Ubuntu Distributive version 2204. Compiler is G++, probably version 9, make, and CMake. Let's start first with the source file, because all our code stored inside the source file. Let's start with implementing the simple task and with some comments. We will create a new file. We will call it source file 1.cpp. It is not the main CPP so far because there is some diagram to explain the code, and I would like to use non-common name for the source file to make it a bit different. So let's start firstly with our main task that we would like to do. We want to print a message. We are planning to write our own program. So first of all, what we need to do is to define a function, which is called main. First of all, we need to define the function main. Why it is needed and why it is main. It is an entry point to our executable file because we have a lot of different applications running on our operating system. For example, this Visual Studio Code, our browser, Messenger, or maybe text editor, and etc. And the operating system should know where it should start to execute a code in the memory. So it is looking for the specific function, let's say entry point, which is called main. You might ask, what does this line mean? I will try to cover it on separate video about the functions in C and C++, but the short information is each function is the set of commands that we would like to execute, and in the end of the execution it might return some value. That's why we have type over the returning value, or let's call it return type. Then we have name of the function. It should be unique in a specific namespace. Then we might call the function with 0 arguments or many arguments. In our case, the main function takes 2 arguments. It is integer number amount of arguments, and then an array of characters with arguments themselves, so we can address them and print on the screen, or maybe read them or do any other operations with it. As the functional block, or let's say the operators block that we would like to group our code somehow, it is curly or slash figure bracket. So we would like to print a message into a screen. We need to get an access to a console, write some data there, then set an interrupt to refresh the screen if we are talking about the whole process. But since this functionality is used by many other programs, we will use already implemented function in a standard library. So we will write here the function printf, and we will call here just a message, let's say hi. And so far you can see that we have our function main defined by ourselves, but where can we find the information about the function printf? For these purposes, we need to include specific header file, which is called stdio.h. Why do we need to use this header file stdio.h? Well, if we will just keep this function printf, not only we will be confused, but also in compiler too, because it will not know, do we provide the right amount of the arguments to this function? Is it requires additional arguments? Does it need to provide any return value? Is the name correct or not? It is quite similar with the situation when we hear the first time a scientific term in exponential growth, and without knowledge about it or determination, we will be confused. But once, or let's say after learning in a few weeks, to be honest, we are able to remember and say, aha, grow, right? So here the same idea. We are helping to the compiler that we would like to call the function printf, which is located on the header stdio.h. So it means when we will build our code, compiler will search for the specific header file where is defined this function printf, and will know that we are using correct amount of arguments. Once we have done this and we included our stdio, we are allowed to call printf function with some text. What is left? Since it is the function and you can see that this function is returning integer value, we should also return some value indicates our behavior, that we executed code correctly. In our case, we are returning 0. It means that we have 0 errors. So when we run our application from the system, it will enter into the main function, will execute function print, which is defined on the stdio.header file. And then since we have returned 0, it means that our application will be exited normally without errors. Okay, so code is written, but how to make it as an executable file and how to run it? So let's take a look firstly at the diagram to see the process needed for it. Then we will do some preparations and then we will build it. Okay, so we are right now in the situation in the developer mode. And we are writing our code. So we have written the source file cpp, and we have, let's say we don't write header file so far, but we're using only source file .cpp. We have written our source file, and instead of the header file here, we're using stdio. So what is happening on the compilation process and linking process? And why do we need compiler and so-called linker? And what is the object file and executable file? Well, we as a developer call our compiler to build our source file into the application, into the executable file. So what is happening under the hood? We call the compiler by specific command, and the compiler runs firstly the preprocessor, which is reading the source file, and for the each include command, search for the header file specified and copy the content of that header file into the source file. Instead of the line include header file, it will place the content of this file. In our case, if we take a look at the code, it means that preprocessor will search for the line include, will find the content of the stdio.header file, copy the content and replace it instead of this line. So here will be a content of the stdio.h. Once it is done, then compiler will read the source file and content of the header file together and will start the compilation process. And means that for each of the command, it will generate the list of the instructions if it is needed to place some variables and define the places in the memory needed, and etc. And as a result, we will get object file. Object file contains list of the instructions per functions and symbols defined. For example, our constants, our name of the variables, name of the functions, and etc. and etc. Once it is done with the object file, the compiler will call linker to link object file and necessary libraries into an executable file. In our case, it might be for windows.exe file, for example, main.exe or maybe something else. In the Linux, it might be any file which has the flag executable and has entry point main. So we call the linker. Linker reads object file, and based on this information and also standard libraries will generate or create an executable file as an output, which we can run after it as a user. So in our system, we don't have compiler and linker yet. But how can we do that? So we can run the console. It is Windows Subsystem Linux Ubuntu or any other Linux distribution. I will show it on the Ubuntu example. Here we will use the command for the package manager to install necessary packages and to be sure that we have them installed. So we call here the command to install necessary packages. The most important part here is build essential because it contains make and C++ compiler. So we are using sudo because we are acting as a super user. Then we call package manager apt-get, for example. Then we call the command install, and we're installing LLDB. It is a debugger. We will use it a little bit later due to its nice interface for the debugging, which is much more friendly if we compare with GDB. And then we are installing meta package build essential, which contains make, compiler, linker, and etc. And we also install cmake to use in the future. So let's call this command and install our packages. So you can see here that it is asked me to install necessary packages. It is quite a lot, but it is absolutely fine for us. So for example, for me, it is make here is written, cmake is written, cpp is written, cpp11. So let's install it. Okay, it is done. And to check that it is working, we can write g++. It is the compiler for the C++. And we can write here -- version. And you can see that we have installed compiler for the Ubuntu in version 11. Good. Now it is time to tell to our compiler to build our code into an executable file. Before doing it, please double check that you are located on the folder with the source file. So if you type the ls command, you will see source file 1.cpp. It is the file that we have written now. And let's call here the magic command first, and then we will try to explain. So we type here g++ o, then our executable, let's call it our executable, and we specify here source file 1.cpp. Here we are using the command, the compiler. We want to build input files. In our case, it is source file 1.cpp, and as an output, we would like to have an executable file with name our executable. So let's run this command, and you can see that there is no so much output, but let's check the file structure. What do we have here? And we see that the executable file was created, our executable. So let's call it and see an output. And we can see the message hi here without new line, and our console continue printing on the same line. Okay, good. With one file it is quite manageable. But what if we have 5 or 10 source files? Even with a few files, it is quite boring to call a command g++ output and source files, and if we made a mistake we need to type it again, or maybe we need to remove files and etc. So let's take a look firstly about one of the diagrams how to build a source file with multiple source files. So let's do a short recap. We as a developer, we are writing the source file, and we can write a header file to include, or we can use the header files already defined by other dependencies or maybe system libraries, standard libraries. Then when we write our source file, we then can compile our source file into executable file. And when we do compilation process, our source files is read by preprocessor, and instead of the each include header file that we have written here, it will search for the content of the file and copy it instead of this line. So then we will have the source file and header file together. If we jump next to the page, you can see that it is a bit simplified. And usually when we have the source file, we don't need to specify to compiler header files because it is already included in the source file. And then the collection of the source file plus header files counts or is named as a compilation unit or translation unit. It means this source file is the unit which will be translated into machine code or assembler code, something similar. Each of the source file is the separate compilation unit or translation unit. Each of these compilation units will be read by the compiler, prepared firstly with preprocessor, then compiled into an object file, which is also counted as a compilation unit or translation unit. And you can see that source file and object file, it is the same content. It is your code, but compiled. And then it will be linked to another libraries, let's say standard library from the C++, which contains an implementation of the printf. So we don't need to type the code again. It will be linked from the library. And then everything will be kind of written into one big file, which is called executable file. In our case, it is our executable. Okay, so with one file it is quite easy, I would say, but what about the several files? So we will go to this diagram. So let's imagine that developer has written several source files. So we have source file 1, source file 2, and some end files. If we will use the command line, what we will need to do, let's say in a good way, is to call the compilation process for the source file number 1, and then compiler will read the source file 1, then search for the header file, then compile it, and then generate object file number 1. Then we will call another function to build the source file and build the object file. So we will do the same iteration that we have, but for the source file 2 and generate object file 2. Then we do this step several times, and then the final file we do again. We read it, then compile it as an object file. And once it is done, then we have our own linking process because we have generated several object files. And now we need to link them together with libraries into an executable file. So we call the link process. Let's say that we can use either G++ or we can use linker executable file. And we specify that in order to link or build our executable file, we need to link all these object files that we have together with libraries needed into an executable file. Linker will read the object file number 1 and take this information somewhere into storage. Then we'll read object file number 2, object file n, and then for the missing implementations, let's say for our case it was printf, we will search for the standard libraries linked to the project and search for this function printf. Once it is found, the code of this function compiled already will be also linked into the some storage. And based on this information, we will get an resulting executable file. Okay, but what if we don't want to write these commands every time? Because software developers really love to automate things. So how can we automate this build process? Well, on this stage, the make comes to a game. We can create the make file, and make file is kind of the recipe file for the tool how to build or let's say how to cook our project in order to get from the source file an executable file. So it stores a list of the recipes or so-called goals. So what is the make? On Linux and macOS distributions, there is the tool which is called make. And shortly, it is a tool which is reading the recipe file called make file and execute either default set of actions, so-called goals, or specified by user. Make might be used not only for the building code, but different set of commands. We can take it a little bit later. And how to use make to automate the build process. First of all, let's try to formulate what we are going to do. we want to call a compiler program to build an executable file from the source file provided by us and create an application file. And we have for it set of the commands for the compiler. So we create a file named makefile, and define there a goal app, which contains the specific commands. So then developer will call a command make, and make will read the makefile, constructing a tree of commands and their dependencies to execute, and then it will read this makefile, then it will execute command after command. So for example, call the compiler to build the source file 1 and generate object file number 1. Then do the same command but for the source file number 2 to read the source file, to compile it into object file number 2. Then build several steps for it. Once it is done, then we can call the linker to link our object files with libraries needed into executable file, and then it is done. From the developer perspective, we just write once makefile and source files, and then to build our code, we just need to call make command without goals specified or with goals specified. And then make will take care of calling commands for the compiler and linker to build our code, which makes our life a little bit easier. So let's go to our code firstly, and we will write our makefile to build our code. So as an input data, so far we just have the source file and we don't have anything else. So let's create here a new file, which is called makefile. And it is one of the standard names for the makefile, or let's say input file names for the makefile. It might be with capital M or with lowercase m. So if we have this makefile, it is also acceptable. But quite often we have by default makefile m, because then in the list of files it will be shown first. So in our makefiles we are defining just two goals so far, is to build our application or our executable file, and then to clean up our source tree and remove this executable file. So we can create here, let's say, a goal app. We would like to use it, and it depends on the source file 1.cpp. So it means if we have this file created, then we can run this command. And here we are calling the command that we used before. So we type here g++-o, then we are calling our executable, and then we specify source file 1.cpp. And let's create another goal which will clean up our source tree. So in our case, we'll call it clean. And here we will just remove forcibly our executable file that we generate. Save this file. More information about makefiles we can take in the different video. But what we are saying that we want to define kind of command or a goal that we want to execute or achieve. It is based on the source file 1.cpp. So here we can write list of files to expect as an input or list of the dependencies. Again, this part might be explained a little bit later. And then with separator, it is the tab symbol, it is important. We are typing command what we would like to do to achieve our goal. In our case, we want to build compiler command to build the source file and link it automatically and make this executable. Another target is clean. So if we will call this command clean, we will remove our executable file. rm is Linux command to remove the file, -f or -f, it is argument, which means if we don't have this file already, so it was removed before, we will just ignore it and will not show any errors. And also we can write here the default target that we would like to call. It will be our app. Let's save this file and we go to our terminal. So we clean up our file, so we'll see that it is empty. Let's remove here our executable file. And before the build file, let's fix a little bit this new line symbol, so we will print our message a little bit more nicely. So we go back to our Visual Studio, go to the source file, and we have this message. So let's add in the beginning of the string, we will add new line symbol. So it is -n. It means we would like to add new line. And also we will add it after, so we want to use new line symbol after our message. So our string contains new line symbol, so we want to have the text printed on the new line, and then we want to have new line symbol after it. Save this source file, go to the console, and now we can just call make, and it will build our application. So you can see we have the command printed by us, so we don't need to type it again. Let's check the file structure and we will see that our executable file was created. Let's call it again, and you see that this command is executed and executed for us. So we don't need to type again and again this G++ or executable file, source file, oh I made a typo, I need to clean it up and then I have a mess. But what if we would like to clean up our file structure? So we can type here make clean, and here when we call make clean we specified our goal. So let's call it and I will show you. And we can see that command rm-f or -f, our executable file was called. When we call make, it is searching for the make files in the current directory. So in our case, we have cpp cmake intro folder, and inside this folder, we have make file. Make goes to this folder that we have, reads make file. Let's go to the make file first, and it searches for the goals that we have and reads this file. It sees that we have app target or goal, then we have clean folder, and we have marked app target or /goal as a default one. When we call make, it goes and calls this default target app. And to call this app, or let's say to achieve this goal, we execute this command. When we call it make clean, we say that make, read please the file make file in the folder, and execute clean goal inside it. So it goes to our file, reads this whole file and finds here clean goal, and then executes this command for us. So we don't need to write this command in the console by ourselves, we just write one command, make or make clean, which is a bit easier. As you can see here, make is quite powerful tool, I will say, but it is quite hard on the beginning to write it in a correct way, especially when it is becoming more and more complicated, because even the small mistake here might cause a problem. So let's imagine that we added here not tab symbol, but just 4 spaces, as you can see here. It is nothing special, we just use it a wrong idea, we use it 4 spaces instead of the tab separator. So we save this file, we go here, we call make, and we see a message that missing separator stop. And as beginners, we might ask questions, what is happening, why it is happening, how can I fix it? Let's go back, and visually it is difficult to say what is wrong here. It might be that we will spend quite a lot of time to fixing. There is of course different tools, extensions to fix it, to help us, but sometimes you have some errors, let's say not here, but somewhere in the names or maybe in dependencies, and it is almost impossible to find it within 1 minute or let's say 5 minutes, so you spend the whole evening to figure it out what happened. But in the same time, I must admit that make is really powerful tool, it is used really widely, and if it is possible, I would also go with make if I can. Okay, but what can I use instead of the make then? CMake comes in the game. It is working as an abstract layer above the build system. So let's go to the diagrams first. Okay, so the short recap, then we have, for example, source files, and we are writing make file. The one, let's say, not a problem, but a special thing about make tool. As a tool, it is quite widely used on Unix system and Linux system, for example, Ubuntu, Debian, any others, CentOS, Arch Linux, on macOS, and etc. But on Windows, for example, it is quite difficult to use it. And also, there are a lot of alternatives to use instead of the make, for example, Ninja or maybe something else. What we can do? So we can go with CMake then. And CMake, it is kind of abstraction layer for the source code. When we use a specific file as an input, so it is cmakelist.txt, And here we are writing our own instructions how to build our code. So we want to build an executable file, we want to build a library, we can cover it a little bit later. We write our own cmakelist.txt with instructions how to build our source file in our project. For example, we want to build executable file, we want to build libraries, we want to do something else with them, and etc. etc. And we provide cmakelist together with our source files instead of the make file. And what is the flow for the developer? Developer, for example, can clone our project with cmakelist and source file, then create a build folder. It is a folder where we will store generated files from the cmake and also our build files. Then in a separate folder, we will call the cmake and specify the folder with the cmake list. Cmake will read cmake lists and generate and create make file for us if we are talking about the pair cmake and make. It might be Ninja, or it might be code blocks, or it might be something else. But the idea is that cmake will generate build instructions for us. Once it is done, it might also configure specific files if it is needed for us. And if we have additional projects, for example, we have a dependency which we are really needed when we are building the code. Let's say it is a Google test framework developed by Google for the unit testing. CMake can download the source code from the version control system for us also. Once it is done, developer can call either cmake build command or maybe even make, or let's say build tool specific command to build specific target. So let's consider an example. If we call cmake build command, then cmake will go to the make files, and for each of the make files that it has generated, we'll call make process to build it, which will read the make file, and based on the instructions already generated, it will compile the source file into object files and will create them. Once it is done, it might use additional projects, for example, Google Test, to build a unit test framework and link it to our project and generate our unit test if it is needed. Then it might use configuration files and then link all objects generated together with dependencies into an executable file for us. It means that we just using an abstraction layer, and then what is happening after, for example, are we using make or Ninja? It is not so important because we have kind of abstraction layer. With this theory, let's take a look at the example. How can we modify our code for it? We go to our Visual Studio as usual. We have our source file. We have make file here. So let's create a new file which is called cmakelist.txt. Please pay attention. It is important that we are using exactly this file name. The cmake is case sensitive for the file name, and we will write here for now just 3 lines and it will be enough. So first of all, we need to define here what minimum version of the cmake is required for our project, and we are doing it by the command cmake minimum required. Here we are typing version 3.10, for example. Why do we need this command? If we go to the terminal for a second and we type here cmake -- version, we can see that I have version 3.22, but you might have 3.10 or 3.0 because different version of cmake is appeared. You might have different distribution of Linux or macOS or even Windows. So there are different versions, and with different versions you have different features added. We are writing here usually minimum version which supporting features that we are using. Okay, so what does it mean for us? It means that if we will call cmake towards this file and cmake will be older than 3.10, then we will stop execution. So we will not configure our project and we will not build it because our version is old. In the same time, if it is the version 3.10 or newer, let's say 3.15, then we will continue our configuration and building. Once it is done, we can define here the command project and name our project. somehow. Let's call it, let's say, CPP intro. And here we can optionally write on what languages we are working with. And here we can also specify on what languages we have the source file. In our case, we are using CXX. It is for the C++ for the different standards. Once it is done, what we need to do, we would like to build an executable file. And now, to make it absolutely easy, and now we want to build an executable file from our source file. How to do that? We just do it quite simple and easy without any complications. We type here @executable. Then we provide the name for this executable. In our case, it might be our executable. And we write here list of the source files which are needed to be able to compile the executable. Here we just write source file 1.cpp, and that's it so far. So we have 3 lines. We have CMake minimum required version 3.10. So if our CMake application is older than version 3.10, we will stop execution. Otherwise, we will continue. Here we're defining the project name and languages that we are using here. It might be C, might be C++, might be Fortran or something else. Then we type here @executable command. It means that we want to build executable file with the given name based on these source files provided. So far, it is ultra easy example just to get a general understanding of the process. Later on, we can cover how can we improve it with using variables and etc. Once we save this file, let's go to our terminal and we call here ls. Now we can see here we have source file, we have makefile from the previous example, and CMake list. To make our source tree clean, there is the de facto standard to create a folder which is called, let's say, build. But we will call here temp build dir. I call it intentionally different and with temp build dir name to visualize you that it is temporary folder which might be or should be deleted later and should be ignored in the source tree in the, for example, Git version control system. We create this folder, go there, and now you can see that we are located in the temporary build folder that we have. And it is empty, of course, obviously we just created it. And we want to configure our project. So in our diagram, we want to call CMake to generate makefile based on our source file and CMake list. So we want to configure it. This part, this big part, is called configure step or configuration stage. This part is calling building stage. Okay, so let's go back to the terminal. We are located in a temporary build folder and we write here CMake and we specify a relative path to the folder which contains root CMake lists. In our case, it is just parent folder. In Linux, we are typing ... So let's call it. It is a configuration part. So if we check here ls, and we can see that it is generated here several files together with makefile and also CMake files. Here it is a folder. But this makefile, it is not exactly the same file that we have written. So for example, if we open it, we can see that it is generated and there are a lot of many lines that we haven't written yet. So it is generated automatically by CMake. And we would like to build our executable file. We have 2 options according to the diagram. We are able to call either CMake build or we can use make command for it. So let's do it both. So we type here just make our executable file, run it, and we see that we have built it. If we check ls, we will see our executable file here. And if we call it, we see the message hi. And if we want to build everything in our CMake project, we can also call here CMake --build . It means we want to call CMake to build everything in the current folder. So let's call it, and we will see that it is also the same because we already built the same target. You may notice that I said in some cases for the make goal or target. It is due to CMake because from one perspective it might be goal in the makefile. In the CMake it is a target, but it is the synonyms. They are using the same functionality, it is the same meaning, let's say, in terms of the building process. Yes, and if we would like to clean our project, we can also make clean. And if we type ls, it is just remove it our executable file, but we will still have here generated CMake file. So let's go to our diagram again. To short recap, CMake is quite powerful tool to have kind of abstraction layer for the build instructions for our projects. It can do quite many things, not only building executable file, it might build also libraries, it might download projects, it might build project for us, it might execute scripts before we build our code or together with building our code, and many other things. What is really cool that CMake can generate make file, or let's say build tool files for us, and we just need to have CMake list and source files in our project repo. I guess it is fine for the beginning, for the first video about build process, for the raw process, starting with just compiler and linker together with makefile and CMake. I hope this video will help you to understand the difference in the build process between CMake based project, makefile based project, and just raw project to building with compiler directly. This is just a start video about build process. I hope to release soon another video about CMake and develop this area, and also about the C++ code, so it will be a mix between two of them. Thank you for your time and good luck.